Hello, everybody. Welcome to IST 110. I'm, of course, Professor S. I do not have my camera on. If you hear some weird noises, I have my dog. He's like right behind me. I don't see any sort of signal that it's coming through, but if you hear weird noises, I am sorry. It's my dog. All right, so anyways, what we're doing in this lecture today is I'm going to go over some of the introductions to just basic programming, like what programming is, parts of it, that sort of thing. Then I'm going to go over quiz prep and then talk about what is due. All right, so anyways, programming. Programs are the things that allow a user to interact with the computer. There's like three main parts to using a program. There's the input, the process, and the output. Okay, so like first of all, when we're thinking about a program, the input, this is the stuff going into the data going into the program. This could be a file, something that's typed on the keyboard. This could be on the click of a mouse, a joystick, like all those different things. Information coming from the network, a touchscreen, anything where data is coming in. It could also be like a file that's already stored on the computer. I don't know if I said that, but it's also an option. And then there's also the next part is process. Process is like thinking about like the computer doing something with the input data. Okay, so it's like usually it's not just accessing data. There's usually other parts that go into it as well, like I don't know, like rearranging things, updating dates, all sorts of different things. Output, that's the part of the program where the computer gives information back. So it's already computed something with something that was inputted, whether it's by a bunch of things that were typed, by something that was clicked, all these different things. It did a calculation, and now it's like giving back information. It could be a graphic. Stop. Glennie. Stop. I'm trying to teach here. Go back to output. So the output's the part that where the program gives information back to the user, and it's not just like a text file. It's not just like a username. What it could be is like a picture. So think about like if you're playing a game, that's a program. Input would be like using like a controller or something like that to move the character. Process is like, all right, well, they pressed right on the right button, so we need to make the character move right, and so the output would be seeing the guy turn right. Okay, all right. There's other ways too that like the output, like it doesn't necessarily need to be seen. Like another thing too is it could be saving a file to disk or drive, or I just realized that you guys don't really use disks, and so it's just not really a thing for you guys anymore. Or it could be like storing something on the network or something like that. The idea is it's data going out. Variables. So variables are super important with programming. It's like designated data space. And like there's like two main flavors, and then I added a third one in there. So like sometimes variables can go in between these. Sometimes it's just these. But like we oftentimes we use these words to describe our variables. So like for instance, a static variable, these are variables that don't change. Okay. Now you can, some of the programming languages, they allow you to create these variables that won't change once you set them, or it could be just one that you know not to change. And so it's a variable that's not changing throughout the whole program. A dynamic, that's the opposite. That's a variable that does change. And then also another thing is like possible with variables or unknowns. Like that's usually when we're thinking about math, like what is this variable? And oftentimes, like some of that thinking you still have to apply to programming because it's thinking, knowing that you want to do something with that container that's going to have that data, but you don't know what it's necessarily going to be in it. And that's just one of the interesting thought processes that goes into programming. Anyways, with programming or with variables, there's two parts. A variable it has a name and it has a type, like a data type. Some computer languages, you have to specify the type. Like for instance, Java, you have to say that here's a variable, it's going to be a integer, or this is going to be a string or something like that. Other languages doesn't really require you to do that. You could just say, here's a variable, store this value to it, and it figures it out. But that for those that you don't have to specify the data type doesn't mean there's not a type associated with that variable. It's just you didn't specify it and it figured it out for you. Computational thinking is creating a sequence of instructions to solve a problem. So it's how do we solve this problem with this thing? And oftentimes the solution is coming up with an algorithm. An algorithm is a sequence of instructions. So like the computational thinking helps you come up with algorithms, apply algorithms, like all these different things. And so the algorithm is actually the sequence of instructions. And some of these can be very simple. Some of them can be could be really confusing. And it's a lot of programming is knowing how to use algorithms, especially when you get into data. So the two most common types of algorithms are search algorithms and sorting algorithms. And they've kind of been around longer than, or at least the sorting algorithms have been around longer than the personal computers for sure. When thinking about like sorting data cards and things like that, there's been mechanical algorithms that have been applied to sort those. And then of course, search is another interesting one. So it's interesting. Anyways, binary. So when we think about computing, we think about the smallest bit of information, and that is a bit, right? It's either a 1 or a 0. Okay, and so it's on or it's off. That's the atomic level of computer programming. Anyways, a byte is 8 bits. So when we were starting to associate letters and characters with what things that we were doing, there needed to be a standard for what we did so that when documents were shared in between documents and programs and information was shared between computers, that you could understand what they were on the different computers. In 1963, ASCII was started with 7 bits, which is about 128. And it was later expanded to 8 bits. And to kind of get an idea of that's 128 may seem like a lot of characters, but it's really not. Like if you think about if you look at the keyboard and all those different numbers and characters, we have 26 different letters. But it's not just 26 different letters. There's uppercase and lowercase, right? So an uppercase letter is going to be different than a lowercase letter. So those are 2 different values. There's also all the different special characters. There's the numbers. And there's a ton that are needed. And then also on top of that is different languages have different character requirements. Like for instance, the Japanese characters that would be needed would be way different than those that would be in Russia. It doesn't necessarily mean that there's not people that know how to speak those languages or read those languages. It's just something, there needed to be a standard so that if somebody wrote something in one language, it could be understood, like they could read it in that language on another computer. So in 1991, Unicode came out. And it was a standard that can represent over 100,000 characters, which is a big deal because, I mean, like if you think about all the characters that we use just typing up a document, there's a bunch of them. There's also all the different characters from that would appear in different languages. There's some formatting ones in there. And then also another one that was introduced is emojis. Emojis are also part of Unicode. And it's been growing ever since then, but Unicode is managed by the Unicode Consortium, which is a nonprofit organization. And it's I guess in 1991 it came at a really great time because that's around the time that the internet started to become accessible to the public. All right, anyways, measuring data. So we were talking about bits and bytes, and so sometimes it makes more sense to refer to the amount of bits being used as opposed to the amount of bytes. So when we're talking about bits, usually it's used for transfer rate. So for instance, on my phone, I have a thing that measures the speed of my internet, and that's helpful to me to know how fast of internet I have. Maybe that means I can't use video during a Zoom call. Maybe that means, I don't know. It could mean all sorts of different things. But it's a valuable bit of information, but it's on bits because it's talking about like the stream of bits coming out of there. With bytes, that's usually meant for storage. So when we're thinking about bytes, we're thinking about like how big a drive is, how big a file is. It's like the amount of space that it takes up. So bits is usually used for the flow of information. Bytes is used for how much there is, like an amount. Okay. And for both of those, what we could end up using is different metric measurements. So like popular one is kilo. That is 1,000 bytes. So a kilobyte is about 1,000 bytes. A megabyte would be 1,000 kilobytes, and 1 gigabyte would be 1,000 megabytes, and so on and so forth. Okay, and that's also would be true for bits. It's just so a kilobit is 1,000 bits, megabit is 1,000 kilobits, so on and so forth. Now, when we're talking about programming languages, there's a few to pick from. But they're kind of divided into two different levels, and we actually get into a little bit deeper, like some of these levels later. But I wanted to make sure it's definitely approached now. So a low-level language is like machine language, which is ones and zeros. Assembly language is essentially the same thing, except it's words replacing it. So if like 010 meant go here, then it would just say, instead of 010, it'd say go here. And so it'd be line by line, lining up. In the high-level languages, these are languages that kind of are more kind of like speaking languages. They work more with English. They're more user friendly. They're also can be more efficient than the assembly code because one line can do multiple lines of assembly. So here are some examples: are C++, Java, SQL, Python, MATLAB, Fortran. There's a lot of them. But usually what they do is they translate, the high-level languages translate their code into assembly or machine language to be used by the computer. All right, now let's talk about quiz prep. All right, so questions covered are going to be brief history on computing, which we covered, I think, on the first day, programming, which was covered on this day, and hardware, which is covered in the next video. Things to study. So make sure you study your notes, old lectures if you need to update your notes, and Zybooks. Okay, so all the lectures will be posted by the time you take the quiz. And so what's going to happen is on Wednesday, here we'll go into the next thing. So on Wednesday, what's going to happen is we're going to meet at our normal time. I'll lecture about hardware, and then once we're all done, I will open up the quiz, and you'll have until 3:50 on Thursday to take it. You only have a limited amount of time. I believe it's 30 minutes to take this one. And oh crap, it says not meeting on Wednesday, but we definitely are. We are meeting on Wednesday. Okay. The due dates are, make sure you have your Zybooks in time for class. And then on Monday, you'll have a new bunch of Zybooks due. Make sure you also finish your introduction if you haven't done that already. And then, again, don't forget to take the quiz. And I'll see you Wednesday. Hey everyone, I hope you enjoyed the video. If you did, please press the like button. It lets me know I'm doing something right. If you have any questions about any of the content, please send an email through Canvas to both me and the rest of the teaching team, and we will get back to you as soon as possible. Do not send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified from when I post the next video. Anyway, I think that's good for now, and I will see you all next class.